Miss Vazone, and today we're going to be graphing a line using a table. Graphing a linear function. Let's go to the next slide. Oops. Come on. My smartboard does not want to work for me. Okay. There we go. Alright, so what does the equation of a line look like? I like to go over this with my students because lines can look very different to them, even though they're all the equation of a line. There's lots of ways to write it. So the first one is y equals mx plus b. That's the most common. X and y are in the problem, m and b are slope and y-intercept. They're numbers. So for example, y equals 2x plus 5. Being a little slow. Alright, so that's one example. Another method, struggling with this one. Ax plus by equals c. This is called standard form. And again, a, b, and c are just numbers. They can be decimals, they can be integers, it can be radicals, it doesn't actually matter. So that would be 2x plus 3.5y equals 11.74. So it can be anything, it doesn't really matter. I hope this does not continue. So that's standard form. Again, notice x and y are both in the equation. Their exponents are 1, and they're not multiplying. They're always adding and subtracting to each other. All right, next one. This is your point slope. So this is the equation. It's very similar to this one, where there's a point involved, and the slope, it's just, instead of using the y-intercept, you can use any point that's on the line. So an example of this one would be y minus 2 equals 1/2 x plus 4. So here, again, there's an x and a y in the problem. They're not multiplying. A lot of times they're away from each other, that sort of thing. And the last one, this one is just describing. So the key is there's an x and or a y in the equation. I don't know what I meant by that. My guess is x equals 7 or y equals -4, something like that. Those are also equations of lines. Those are horizontal and you're vertical. Alright. How many solutions does a line have? So it's an equation, it's linear, but unlike an actual equation you solve, there's not just one answer. Okay? When you have the reason we have lines, where is it? Did I not put it? Okay. There is an infinite number of solutions. Think about it. If you have y equals 2x plus 3, how many different numbers can you plug in to make that equation true? I can plug in 1, 5, that'll work. I can plug in 2, 7, 3, 9, -12, whatever. There's an infinite number of things. And that's why we draw a line. It represents every possible answer. If we had 4 equals 2x plus 3, there's only one solution. X has to equal 0.5. It has to equal 1/2. Otherwise, nothing else works. But with a line, because there's 2 variables, you can plug in as many things as you want. Okay? Alright. So, which ordered pair is a solution to 3x minus y equals 7? This is the type of problem you'll see on a standardized test, that kind of thing. So, how would you approach this? It's a couple ways. Easiest thing to do, just plug in. See which one works. So, if I plug in for this first one, 3, and then what's the x value here? Well, it's x comma y. So 3 times 3 minus 4. Does that equal 7? Don't think so. 9 minus 4 is 5, so it's not A. Let's try B. 3 times 1 minus negative 4. Does that equal 7? Pretty sure it does. This is 3. A double negative turns into a plus. So that works. So the answer is B. And it's helpful if you want, you can go through and check the others. This would be 15 plus 3 is 18. That doesn't work. Negative 3 plus 2 is negative 1. So that one doesn't work either. So just plug in, replace your x, replace your y. Alright, so we're going to graph the equation negative 2x plus y equals negative 3. So what we need to do is figure out what points are on the graph. So one thing I like to do is let's solve for y. It just makes life easier. So let's get the y by itself. So what I'm going to do is I'm just going to add 2x to both sides. So y equals 2x minus 3. And then let's just pick some numbers. I usually like to use 0 and pick numbers that are good points that are going to be on this. So pick some numbers. It doesn't matter what they are. We can do negative 3. We can do negative 2, 0, 5, 6. It doesn't actually matter what you pick. It helps to keep them, my graph is 10 in every direction, so I want to keep my numbers small. And then let's just plug the x in and see what we get. Use block. So 2 times negative 3 minus 3 is, that's negative 6 minus 3 is negative 9. 2 times negative 2 minus 3. That's negative 4 minus 3 is negative 7. 0 is nice, right? 2 times 0 minus 3. That cancels out. We just get negative 3. 2 times 5 minus 3. 2 times 5 is 10. Minus 3 is 7. And last one, 2 times 6 minus 3. That's 12 minus 3 is 9. Now that I have my points, I'm going to plot them and draw the line. So remember, this is my x and this is my y. We're just plotting points. So my first point is negative 3, comma, negative 9. So on my graph, I'm going to go over 3, 1, 2, 3, up 9. And familiarize yourself with your graph. I know that this is 10 by 10, so I can just jump up. Oh, if this is 10, whoops, I did that wrong, didn't I? So negative 3, I know this is negative 10, so I just have to go up by 1 to make it negative 9. Negative 2, negative 7, 2, 4, 6, 7, 0, negative 3, so just down 3, 5, 7, 3, 4, 5, 2, 4, 6, 7, and 6, 9. So those are some points on my line. Draw a nice, make it as straight as possible. Nice extend, make sure you put your arrows because those are infinite solutions. Every point on this line is a solution to that equation. Alright, next one. Why don't you try it on your own? Or at least pause the video and pick some numbers that you think will be good. So since my slope, or my, I have a fraction in front of my x, think about what would be good numbers to pick. Right? We want to make our life easy. Right? I'm not given my x's, I'm picking them myself. So pick numbers that are nice. So I'm going to pick things like negative 8, negative 4, 0, 2, picking numbers that will make my life easier. -1/2 times -8 plus 4 equals. So half of 8 is 4. Since I have two negatives, it's positive 4. 4 plus 4 is 8. -1/2 times -4 plus 2. Half of 4 is 2. 2 plus 2 is 4. -1/2 times 0 is just 0. Plus 4 is 4. Oh, I messed up, didn't I? Let's fix that. This was plus 4. So that's 6. Okay. 2 plus 4 is 6. 4. -1/2 times 2 plus 4. Half of 2 is 1. It's -1 plus 4 is 3. And last one. Half of 10 is 5. -5 plus 4 is -1. I'm really not doing so good with changing my colors, am I? And those are my points. Okay? So again, I picked all even numbers since I know half of an even number is going to come out nice. Could I have done like 7? Sure, but then I'd have -3.5. That's annoying. I don't want to have to deal with that. So pick stuff that will make life easier. Alright, so now we're going to plot -8, 8. So starting at 0, 0, -8, up 8, -4, up 6, 2, 4, 6, 0, 4, 2, 3, 4, 2, 3, and 10, -1. And that's it. So it doesn't matter what you pick, just make sure you plug in accurately. Alright, next one. The distance in miles that a runner travels is given by the function d = 6t, where t in hours is spent running. The runner plans to go for a 1.5 hour run. Graph the function and identify the domain and range. So, how far is he going if he's traveling 1.5 miles? So we really only need 2 points. So at time, this is our time, this is our distance. At time 0, how far has he gone? 0. At time 1.5, how far has he gone? Well, they gave you the equation, 6 times 1.5 equals 9. So all we have to do is plot those 2 points. So I have my 0, 0, and 1.5, 9. And you could do it this way, or you can scale your graph. You know you're only going over 1.5. You could do like 0.5, 1, 1.5, or go up by 0.25s, whatever you want to do. And that's my graph. It's kind of awkwardly small, right? Now, notice I didn't put an arrow. Why do you think I didn't put an arrow? What would an arrow represent? An arrow would represent this person running forever, and he stops, right? He's stopping after an 1.5 hour run, and that's long enough, right? Even if you go in a marathon, you have to stop eventually. So that's why that's a dot, okay? So that represents the graph, assuming each box is 1. Now, the domain, it represents what? The domain is our t. So the domain is your time, and he's going from 0 to 1.5 hours. The range is how far, right? The distance. So how far does he go? Well, he starts at 0, and what's the farthest he goes? He goes up to 9. That's That's using the word problem. Alright, we got one more. Oh, no we don't, just kidding. Alright, graph y equals 2. So, the y value is 2. Can the y value be anything else but 2? No. So I know my y value is 2, but what's x? Pick random numbers, right? Like we said before, -3, -7, 4, 8, 10. Does the x value affect the equation? No, it doesn't do anything. Like I try to plug in -2, there's nowhere for me to plug it in. So really, it's just the x's and the y value is always 2 no matter what. So I have -3, 2, -7, 2, 4, 2, 8, 2, 10, 2. If I draw this line, it's just a horizontal line, right? The y value, no matter what the x value is always 2. X value doesn't really mean anything in this case. How about this one? X equals -1. So my x is always -1. What's the y value though? If I plug in -1, I have -1 equals -1. The y can be anything. -8, 4, 0, 10, -3, doesn't matter what it is. So basically, instead of a horizontal line, what's this one going to be? A vertical line. My x value is -1 at all times. Alright, the y value does not matter. All that matters is that my x value is always -1. Okay. And that's it. Hope that helped, graphing lines using a table. Have a great day.